Hi guys, it's me, Grandma Lily, and it's time for Story Time with Grandma Lily. And yep, that's where we are now. So it is quarantine day 473. And the only thing that I can tell you is that hopefully within the next couple of days, the headbands will be prettier. Other than that, this is where we are. So now yesterday I read a story for my friend Dina, my cousin, because it was her birthday. And that was because my cousin Lynn told me that it was Dina's birthday. But Lynn misunderstood my question, and it turned out that yesterday was not Dina's birthday. Yesterday was actually Lynn's birthday. How do you like that? So, because yesterday was Lynn's birthday, we should have read a story for Lynn. Thing is, Lynn's favorite story is Where the Wild Things Are, and we've already read that. So, I had to pick out another book that I thought that Lynn would like for her birthday. This one is a little bit long, and if you're not really interested in this subject, you might not want to pay attention to the whole thing, but I found it really interesting, and I learned a lot from it. So the name of tonight's book, people, is called Stars, and it is all about stars and the universe, and I think it's going to be really interesting, and I think we're going to learn a lot. So before we get started, I love you. Elijah, Jordan, and Kylie, I miss you. I can't wait to hold you again. Serenity, I'm pushing through. I hope you're pushing through. We're almost done. And so grab your blankets, grab your cookies and milk, lay down on Mommy and Daddy's lap, and we are going to learn about stars. And the name of this book is Stars, and it's written by somebody named Michael George. And that is what the first page looks like. Look at that. That is gorgeous. Stars by Michael George. In memory of George R. Peterson Sr. So this is it's in memory. That means that that person is not alive anymore and that they wrote this book for them. That's very nice. Since the very beginning of humankind, we have been fascinated by the stars. Twinkling in the dark night sky, the stars evoke questions that beg to be answered. What is a star? Where are they located? And what is their significance for life on Earth? In the past few centuries, scientists have answered many of these questions. The answers reveal the intricate workings of our universe and the delicate balance of life on Earth. So on this page is an open star cluster, and on this page is our galaxy. Look at all those stars. Many people think that stars are visible only at night. One star, however, can be seen only during the day. That is the star we call the sun. The sun is an enormous ball of hot, glowing gases. It is large enough to hold over 1 million Earths and hot enough to warm our planet and light our sky. Without the sun, the Earth would be frozen, the sky would be black, and life would not exist on our planet. Despite its unique appearance and importance to life on Earth, the sun is just an ordinary star. It is no different from the stars that are visible every night. The sun appears to be bigger and brighter than all the other stars simply because it is the closest star to the Earth. Like the sun, all stars are extremely large, hot balls of glowing gas. Sometimes I say that about my dog. And there's the sun right there. On dark, moonless nights, we can see about 2,000 stars in the sky. However, there are countless other stars that cannot be seen. In fact, many of the specks of light in the night sky are actually two stars. The stars in these pairs, called binary stars, circle around each other in space. Most binary stars appear to be single stars, simply because they're so far away from Earth. There are also many specks of light in the night sky that are actually 3, 4, or even more stars. These groups of stars are called multiple star systems. Some star systems, called globular clusters, may contain millions of stars that are visible only with powerful telescopes. So here you can see in the sky, you see this really bright spot here? That is what this looks like. That is a star cluster. That's kind of cool. The largest star systems in the universe are called galaxies. Our solar system, which includes the Sun, the Earth, and the other 8 planets, belongs to the Milky Way galaxy. If you look into the nighttime sky, you can see part of the Milky Way. The galaxy looks like a huge hazy cloud stretching across the sky. The Milky Way is only a faint glow because the stars are very far away. A common telescope reveals that this hazy cloud is a connection of billions of stars. Scientists estimate that the Milky Way galaxy contains 200 billion stars. That's a lot of stars. If you counted one star every second, it would take 6,000 years to count all the stars in our galaxy. That's what the Milky Way looks like if you could see it. Although it is difficult to comprehend all the stars just in our own galaxy, the Milky Way is not the only galaxy in the universe. Peering between the stars in our galaxy, scientists can see other galaxies sprinkled throughout space. Scientists estimate that there are 100 billion galaxies in the universe, each containing an average of 100 billion stars. In all, there are as many stars in the universe as there are grains of sand on Earth. That's not on one beach, kids. That's on the whole Earth. That's a lot of sand when you think about the fact that there's a lot of deserts out there. As we have learned, all of the billions upon billions of stars in the universe, the sun is the closest star to the Earth. However, the sun is still 93 million miles from Earth. If we traveled in the fastest spaceship toward the sun, it would take many years to reach its surface. This is the Andromeda Galaxy. Look at that. That's pretty cool. The light that we see from the sun travels 187,000 miles every second, or nearly 700 million miles per hour. That is much faster than any spaceship has ever gone. In fact, nothing on the universe can travel as fast as a beam of light. Although light from the sun travels incredibly fast, it still takes some time for it to reach the Earth. The light that we see from the sun has been traveling through space for just over 8 minutes. These rays of light are actually images of the sun. Therefore, we do not see the sun as it is at this moment. We see an image of the sun as it was about 8 minutes ago. How red the sun is. The stars we see in the night sky are millions of times farther away than the sun. The light we see from the star closest to the sun, called Alpha Centauri, left the surface over 4 years ago. Therefore, we see Alpha Centauri as it was 4 years ago. Other stars are so far away that we see them as they were thousands of years ago, when our ancestors lived in caves. Some stars are even farther away than this. We see those stars as they were before life existed on the Earth, or before the Earth was even formed. Our planet changed drastically in the time it took the light from distant stars to reach it. Similarly, the stars have also changed. In fact, some of the stars we see in the sky may not even exist any longer. This is because stars, like people, are born and eventually die. During their lives, stars change in remarkable ways. So how do you like that? Some of the stars that you see when you go out and you look in the sky at night, they're not even there anymore. A star is born in a giant cloud of gas and dust called a nebula. Nebula, the plural form of nebulae, the plural form of nebula, consist mainly of tiny hydrogen atoms, but contain other microscopic particles as well. Within some nebulae are small, dense balls of dust and gas called globules. Just as Earth's gravity pulls objects toward the ground, a globule's gravity pulls dust and gas toward its surface. Bit by bit, the globule grows in size. After millions of years, the globule is a dense, heavy globe, hundreds of times larger than the Earth. Look at that. Wow. As the globule continues to grow, matter in the globule is packed closer and closer together. With the pressure constantly increasing, the temperature at the center of the globe begins to soar. Eventually, the core becomes hot enough to set off a chain of nuclear explosions. In a process called nuclear fusion, hydrogen atoms combine to form a completely different atom called helium. Nuclear fusion releases tremendous amounts of energy, and the star begins to shine. These are all different types of galaxies. Look at that. Once a star begins to shine, its surface churns with currents, turbulence, and gigantic waves of gas. Occasionally, thick clouds of glowing gas burst above the surface. As these blazing sheets of gas drift above the star, violent storms rage across the surface. These storms, called sunspots, look like dark patches because they are thousands of degrees cooler than the rest of the star. Sometimes sunspots erupt with violent explosions that send streams of particles and radiation far into space. So these are sunspots, and this is what's called a solar prominence. Right here in this box, a solar prominence. As the surface of a star erupts with activity, nuclear fusion moves out from the center of the star toward fresh hydrogen fuel. Meanwhile, a growing core of helium ash is left behind. After about 10 billion years, most stars begin to run out of hydrogen fuel. With less energy flowing toward the surface, the star begins to contract. As the core of the star is squeezed tighter and tighter, the helium ash grows hotter and hotter. Eventually, the temperature becomes so hot that helium atoms begin to melt together, forming completely new atoms called carbon. This releases more energy and causes the star to burst, similar to a piece of popcorn. Have you ever watched popcorn pop? It gets really, really, really hot, and the pressure builds up, and then it goes pop. Enlarged stars such as these are called red giants. Red giants are enormous stars. Even when compared to the sun, most are about 40 to 50 million miles across, or about 50 times wider than the sun. Some red giants are even larger than this. Betelgeuse, the red giant closest to the sun, is 250 miles across. If Betelgeuse were in the place of the sun, it would engulf Mercury, Venus, Earth, and Mars. I wonder what would happen if we called it 3 times. Maybe we should go outside and say, Betelgeuse, Betelgeuse, Betelgeuse. Nuclear fusion cannot continue forever in the aging star. Eventually, most of the star's helium fuel is converted into carbon. Once again, the star begins to contract and temperatures begin to rise. However, carbon atoms do not ignite easily. Soon, temperatures become so hot that the star explodes and hurls its outer layers of gas into space. The expanding cloud of gases appearing round and planet-like is a planetary nebula. The remaining star, now called a white dwarf, shines dimly through the cloud of gas and dust. A white dwarf has no source of new energy, but continues to glow simply because it is hot. Given time, the white dwarf loses heat into space and finally turns into a dark globe, a black dwarf. Average size stars, such as the sun, how do you like that? The sun is an average-sized star. Follow the life cycle described above. Stars that are 2 or 3 times larger than the sun have a different fate. Under the crushing weight of a massive star, temperatures rise so high in the core that carbon atoms undergo nuclear fusion. They fuse together in a variety of other atoms. This releases additional energy for a time, but eventually, even a massive star runs out of fuel. So this is called the Veil Nebula, and this is called the Trifid Nebula. This is the Veil Nebula on this page here, and this is the Trifid Nebula there. After all the nuclear fuel in a massive star has been used, the central core is crushed by the star's tremendous weight. This sets off a violent explosion called a supernova. A supernova makes the star millions of times brighter than normal and hurls the outer layers of the star into space. In some cases, the core of the star is also shattered. In other cases, the supernova leaves a tightly packed ball of matter called a neutron star. Neutron stars are only 6 to 12 miles across. Although they are very small, neutron stars contain more matter than the sun. A single drop of a neutron star would weigh billions of pounds on Earth. Like a white dwarf, a neutron star has no source of new energy and can only cool with time. This is a supernova right here, and these are some other galaxies. Stars that are 10 or 20 times larger than the sun live in the most dramatic fashion of all. When a star this massive runs out of fuel, the tremendous gravity of the star causes it to collapse. As a star is packed tighter and tighter, the gravity of the star grows continuously stronger. Soon the gravity is so strong that the star itself is crushed out of existence. All that remains is the star's intense gravitational field, known as a black hole. The gravity of a black hole is so strong that nothing within a certain distance can resist its pull. A black hole can engulf stars, planets, and entire solar systems. Whatever enters a black hole is lost from this universe forever. Nothing, not even a beam of light, can escape. This is a spiral galaxy, and it is in Leo. Whether they are like our sun or much more massive, all stars change in dramatic ways. During their long lives, stars transform hydrogen into helium, helium into carbon, and carbon into a variety of other elements. In the last stages of their existence, the stars hurl this newly formed matter into space. Once shed by a star, this material drifts through space as a thin cloud of gas and dust. Given time, it combines with the remains of other stars to form a nebula. Here are some nebulae. As we have learned, a nebula eventually condenses into a new star. Our sun is one of these newer stars. The nebula that condensed into the sun also formed the Earth and the other planets in our solar system. This nebula contained carbon, oxygen, and all the other elements we now find on Earth. These elements, created long ago in aging stars, are the basic building blocks of everything on Earth, including human beings. And so, in a way, we are all made of stardust. And these are some galaxies in space, and this is a Lagoon Nebula right there, and these are some other galaxies. Stars are more than just specks of light in the sky. Every star is an evolving ball of hot glowing gases. During their long lives, stars create the elements from which the planets and we ourselves are made. The stars also hint at the immensity of our universe and suggest the vastness of time. The next time you stare into the night sky, consider infinity, consider time, and consider life. And this picture is of Carinae Nebula and some other stars. And that is the end of our book. And so, guys, we learned all about stars today, and I learned some things I didn't know. Did you? Like, I learned a bunch of things about stars. And so that is a story that we read for Lynn today. So we want to say happy birthday, Lynn. And we love you. We love you so much and we miss you. And so tomorrow we are going to read another story. I don't know what it is, but I heard a rumor that it has something to do with a mouse and a cookie. I'm not sure though, so we'll have to wait and find out tomorrow. In any event, I hope you have a wonderful evening. Tomorrow is Wednesday. Enjoy the day, and Grandma Lily loves you. Bye-bye.